This is the Amp Hour Podcast. Released February 9th, 2020. Episode 478. Optimization Beast.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
2 weeks in a row. This is a record.
Yeah, it's been a while, man. What shall we talk about? How about some electronics? Something different.
Do we have electronics? I don't know.
We've got chips we're going to talk about. I've got firmware I can talk about. I've got, you've got, moving your lab, maybe.
I've got keypad design to talk about.
Yeah, keypad that came out recently. So I think we're gonna maybe we should start to recap beforehand. Get people interested in this thing.
We still have no plan or notes for the show. We're just inherently lazy, aren't we?
We're more post hoc,
Right. Okay.
Yeah.
And a bit of a news from last time. We did announce that we're going to get an editor for the Amp Hour. We don't have one yet, but you're talking to someone tomorrow who has bona fides in the industry. So yes. So you did have you did get some responses to the request. So on the EV blog forum and. Yep. Oh, can we start it? Before I forget, can we? I know we don't just want to rehash stuff I've done on my videos and stuff like that, but it's inevitable, I guess.
Yeah, it's what you're doing, so I think that's fine.
Yeah. Can we talk about my impersonation scam?
Oh, I didn't watch that one, but
no, you didn't watch it. Okay.
Yeah. So is it someone actually trying to impersonate you?
Somebody impersonated me.
Yeah, I've tried to do your accent on here. It's gone very poorly.
Oh, okay. And so okay. Here's the TLDR. Did I get that right?
Yeah,
Too long didn't read. Yes, I did.
That's right.
Oh,
yeah.
I'm hip and down with the kiddies lingo.
Mm-hmm. Yeah,
all right.
Yeah.
Anyway, somebody who I know who it is now, they impersonated me. They set up a Gmail account, dj.eevblog@gmail.com. So, to look similar to my, to make it look like it's me, kind of thing. And they faked a footer as like an email footer as well, saying, David Jones from EEV blog, linked in the website and all that sort of jazz. And they contacted a company who shall remain nameless, who I've dealt with before, and they requested confidential technical information from the company. And the company, believing it was me, sent it to them in good faith, right?
Oh my.
So this is fraud to, get, confidential company information.
Oh my!
So, and they got away with it. The company sent it. And I won't say what it is, but anyway, they got away with it. It's actually rather clever. It's one of the oldest scams in the book, impersonating someone. It's social hacking,
exactly,
kind of thing. Yeah.
Yeah, the same thing happens for phishing too, right? It's looks like it's legit enough, and then
it's a variation of spear phishing is the term.
Okay.
Anyway.
Yeah.
So, pretended to be that. And if the company simply, Google search that email address, they would have known that doesn't exist and I've never used it anywhere. So that should have, rung some alarm bells. But, it did it. It got through quite a few people in the company and they got the information and they sent it to them. The only reason I found out about this is because somebody in the email chain, I had multiple people, copied in my real email, and so I got copied in the middle of this email exchange, and it's like, whoa, what's this?
Yeah, that's pretty crazy.
And they're talking to me. They go, "Oh, Dave, we've got a new product coming out. Would you like to have a look at it?" All that sort of stuff. So
yes, I would. Yes, I would.
And so as it turns out, I had a hunch about something. Given my middle name is Sherlock Ohms. Get it? Ohms.
Yeah.
Anyway, I'm here all week. And my hunch turned out to be correct, and I was able to track down this person And hilariously, so I found out their real email address. So I sent them an email, and within the hour of sending that email, I was watching in real time as they tried to erase the evidence. So this is elite level hackery here from me,
Sure.
Yeah. Anyway, yes. So it's rather hilarious. And then I got another email, and then I sent another email to them saying, "Hey, I'm watching." and then they sent an email back going, "Oh, my Gmail account was hacked," and like the oldest excuse in the book, "My Gmail account was hacked," and "Oh, sorry for the inconvenience." It's like bullshit. Anyway, it's rather hilarious. So yeah, this is a real thing.
I'm glad you got copied on there. That would have been bad otherwise. Yeah.
Yeah, no, it's so I could see this having big implications in. I'm sure there are big companies that have been hit by this by competitors and whatnot, or from people who want to get advanced information on products and things like that.
Sure.
Like I used the example in the video of like if Apple's releasing a new iPhone and they pretend to be a 20 million subscriber YouTuber phone reviewer or something, and they get all the advanced information and all that sort of jazz, and that can be a big coup.
So what I'm hearing here is crime pays, huh, Dave?
it could potentially pay. Anyway, I did a video just warning companies actually be aware of this, because this is
Yeah, how often do you look at a email address like specifically if it just shows up as like from Dave Jones or well, they don't care about email from me.
Right. And they were quite clever in that they actually did some research to find out who in the company I would have contacted and stuff like that, and they just dropped their name in the email, in the original email, like to make it more persuasive that it's actually me.
Right.
So so it was rather clever. Anyway, I'm watching. It's just absolutely hilarious. I was able to track them down. So enough of that.
Well, how goes so you're moving labs maybe too?
I'm potentially moving labs because I get the keys to my old lab back this weekend. So it is now vacant again. The lawyers who were inhabiting that have now gone. They didn't last very long. They flew the coop. And my lease here finishes in 7 months or something. Finishes in October or something like that. So I'm just deciding what to do, because David's left now. So I've got this 100 square meter lab, which is like pretty big for one person.
Yeah, right.
And I would love to keep it, but it's expensive, and I'm trying to keep business expenses down as much as possible. So it's one of those trade-off things. I mean, who wouldn't want a bigger lab, right? There's no such thing as too big a lab.
Yeah.
Never, right? Said nobody ever.
Right. I think there's the it's like a volume of a fluid will fill the container it's in.
Yes.
Right?
Yeah. Exactly. The crap will expand to fill the space available.
That's right.
Term.
Yeah.
Right. Which is the case here. I still, even with 100 square, I still have that old-fashioned snake-in walking trail through the lab. So everything's on the floor, and I just have like a trail. They're just pushed aside, and I have a trail going.
Yeah, I can't do that. Anything on the floor like floor stuff really bugs me. That's like my first cleanup move. Anytime I'm like cleaning anything up, it's like just get it off the floor, even if it's just because it's psychological and it like goes up on a counter or something. Yeah. Because if I get restrained and like where I can walk, and it's just that really that part really bugs me for some reason. I don't know. I don't know what, because I'm not a clean person.
Right.
Yeah.
Oh, I cleaned up the bunker on the weekend.
Oh, yeah? Okay.
Yeah. I thought, bugger it, I'm going to... Well, I started throwing things out. And I had 15 monitors in there. 15 computer monitors that I'd got from the dumps, and I went, no, this is a sickness.
I wasn't gonna do an intervention or anything, but I don't know what your plan is for all that stuff, but it's like you're not harvesting components off of them.
Yeah, I know.
All of your dumpster diving it has consequences, Dave.
It does have consequences, and I realized that after all these monitors, 15 of them, so I decided, bugger it, I'm just going to give them away. So I gave them away to a worthy cause who needed these things. Yep. So they came and picked them up, and Yep, gave them all away, so they will be recycled and used.
Great.
For kids, actually.
Yeah,
So
even better. Yeah,
it's great.
Yeah.
So that was my first move in cleaning up the lab, and I tossed a few other things out. And I've got more to go, of course, but so that's part of my process. But anyway, the audience out there, tell us how is your lab just organized chaos, or do you can't stand it being like that? Do you have to have everything labeled and categorized? And
I would be willing to bet that that's part and parcel of like how much space there is too. I think that when you have more space, you feel a little bit more comfortable letting things go. Like
of course, yeah.
I had like my tiny lab in my old apartment, and like any amount of clutter, well, it was already pretty cluttered, but any like extra clutter past the organized clutter, and it was just like you couldn't do anything then. It was like literally you couldn't
that's
move.
right.
Yeah.
Well, I used to be like this when I was in the garage, right? I was working for a couple of years out of the garage, and longer than that for my hobby and contract stuff as well. Yeah, I had like a 5 square meter lab, right? 5 square. I don't know what that is in feet. Sorry, but yeah, the 5 square meters is tiny. Like it is one.
10. I think it's times 10.
Right. It is 1/10 of the size of my old lab, which you've been in.
Right.
So which is 50 square meters. So it's 1/10 that size. And you had no choice but to organize things and keep it clean.
Yeah, exactly. Right. And it's I think there's some benefit to that. I mean, some of it's just me convincing myself these days. But like the need to like clean up at the end of the day and stuff like that too. I think we've talked about that on here before. Like there is at least a forcing function there where you have to kind of like close things down. I think the only downside to that really is when you're doing like a long-term test. If you're doing like a battery drain test or something.
That's why I need quite a few benches. I've got like 6 benches because like it's where you put your work in progress stuff.
Yeah, but I think that the it's easy for me to be like, oh, well, everything's a work in progress.
Exactly. Yeah, that's right. I know it can get carried away, but
I saw a really sweet modular setup recently where it was like a build plate. I can't share too much about it, but it was like a build plate, and then it was like they had prefabbed like cables that were like on their bench, and then every build plate they did for a project came over to the bench. It was like really,
right,
it was really nice.
Yep. Yeah. I've done that in companies where everything's like really formalized and stuff like that. And a lot of companies will have a clean desk policy. At the end of every day, your desk must be clean.
Wow.
Yeah, everything has to be put away. It's it's once again it's that forcing function. So yep. So please let us know in the audience.
And some of that's security, I think too, right?
Oh yeah, it can be. Yeah. Well, I've worked in that where you work on secret classified stuff, right? And you like it has to go in the locked safe at the end of every day. If you're not using it.
Yeah, so, I've never worked on that. What is that like in general?
Oh, you don't have to do it that often because you don't have to reference the classified material, every day. But when you do, you can't leave it on the desk overnight. You can't leave it in your drawer. It's got to go back into the locked security cabinet, with the combination and the whole works, right? Yeah. So
I read in that Skunkworks book, they actually talk, the guy who wrote it was like the former director of the lab. I don't think it was the stealth program, maybe it was the SR-71, but he specifically was pushing for not having it top secret because like the amount of like overhead that you had to have, and like like the same thing, you need like security officers, you need to be like audited all the time. Of course. It was just like he was pushing really, really hard. And if I have not promoted that book enough on here, it is a fantastic book.
You were promoting it to me again personally the other day.
You would love it, man. That is like in terms of like nonfiction, it's like perfectly aligns with like nerdy but like historical and like I don't know. And like the SR-71 is just like the most amazing machine.
Of course, yeah.
The fact it was built in the 60s, like it's just so unbelievable like that they built that thing. And it was, and the interesting factoid about that, right?
What?
It was actually the RS-71. Yes. That was the official name. And then a general put it backwards on a piece of paper.
I didn't know they put it back right.
They changed everything because of that one mess up, because they didn't want to make the general look bad.
Okay, I didn't know that.
Isn't that amazing? Like,
oh my God. That's pretty good.
It's so bureaucratic and ridiculous. Yeah.
Great.
Yeah.
We have some news. Straight off the teletype. Sad news, unfortunately.
Unfortunate, yeah.
We do have another passing of an analog legend, Barry Gilbert from Analog Devices fame, among other things. The Gilbert cell.
What is the Gilbert cell, Dave?
the mixer. I'm not an expert. Come on. It's a mixer. It's a mixery thing. I'm not.
I asked actually quicker because I was like, I don't know what the hell that is.
It's an analogy mixer used in chip design and stuff like that. Oh yeah, well, you could do it discrete, I'm sure, but yeah. Anyway, yes, just passed away, aged 82, unfortunately. So we'll link in a couple of videos. I've got another video for you here, another presentation. Somebody put it on the forum as well. Mm-hmm. But we've got a couple of videos. You can watch him talking about translinear, 55-minute lecture on translinear circuits for all you translinear fanboys out there. I'm sure there's a lot. It's a really nice presentation. So yeah, that's on the they've hosted that on the Computer History Museum, which is a good source of stuff. If you don't subscribe to the Computer History Museum, they release tons of stuff. It's just amazing. Tons of interviews.
So we had talked about when Tom Lee was on the show, and it was just me and Tom, but Tom is out doing a lot of interviews with like people that are getting older in the industry and, just to make sure he preserves knowledge. This is actually something that the Computer History Museum as well does, like Dave's saying. And it's just like, it's historical archiving where you're not going to get that knowledge otherwise,
Of course, yeah.
Like there's just so much latent knowledge out there that is unfortunately passing away. And so it's really good. I mean, let's support the Computer History Museum if you can. It's great to watch those old videos too. I think that was one. I think Jim Williams and Bob Dobkin did a video set on there too before Jim passed away. And it's just like a lot of these older engineers were like, why would I be interviewed? Like it's like they obviously have stories, but I think that these are not people who have the limelight. They're not like.
Of course, yeah.
They're not egocentric like Dave and I. And they actually were talented.
Exactly. Unlike us talentless, hacked social media people.
Yeah, well, Dave, we get stuff in the limelight. We need to highlight things, but yeah, that's really great about these interview series. And so I'm really excited about hearing from Tom as well. Once that goes up, he's going to try and talk to all the old Tektronix engineers and stuff like that are still around. So, yeah. A lot of them are what is like the top tier usually for like it's like staff scientists, but then it's like emeritus effectively. Like a lot of them are like
yeah.
I think maybe even Barry was listed as this at one point, but they're like like lifetime appointment of like awesomest engineering kind of thing. So that's how you usually find them. Usually find them at companies listed like that. They're like, we just want their name on our webpage, and they still come in once in a while.
Yeah, of course, that's right. Give them an honorary title and
give them a cube, let them come in. Like keep them telling stories and showcasing what they know, and
cool.
Yeah,
I think Analog built a dedicated R&D factory just for Barry. I think just so that it could lure him back or something like that. I think I read that. They wanted to lure him back, and they so they devoted a whole R&D facility.
It never like ceases to amaze me what companies will do when it's like when someone's important enough. I saw like a smaller version of this today, but it was on Twitter. It was like the bus schedule for like how far people get bused into the Bay Area. And it was like, people like 3-4 hours outside, they're like.
Really?
Oh, yeah. I mean, just because I think it's a combination of people that are living that far out because they want to be in nature, but also because it's cheaper housing. But then there's these buses that you get on, and you're just like, you could do work on them. They're comfortable places. But,
right.
But holy crap, like that's insane.
I know. That's a big chunk of your day just traveling. That's insane.
And so that's one thing. But then, you'll see this as well. It's like, there's a chip design center in like, I don't know, like middle of nowhere, Montana. And it's like, well, where did that come from? It's like, it's a one person office.
Oh, right, okay.
Okay.
Right, because that one person that they couldn't dare,
Exactly. They're not working from home. No. They're not working from home. They are working at a company office that just happens to have one employee in the middle of nowhere. Like,
Yeah.
And I think that like that's how a lot of companies get. When I think about some of the people I've worked with, and they're just like they're just so hard to replace. And
Yep.
So the companies are like, well, what's our option here? We can either pay them as much money as they want, and then eventually money stops having its luster. You pay someone a couple, a lot of money, and then eventually they're like, okay, well, what else can we do to keep them around? And it's like, well, maybe they can live somewhere else, or and it's
that reminds me, my mate Doug Ford, who's like an analog guru, right? Mm-hmm. He used to be the head designer at Rode Microphones, right? Mm-hmm. He used to design all their mics and stuff. And of course, that's a pretty important position.
Right.
Right. Like it's the important position, right? He was the number one person there that designed the products, and he decided to move on and leave, and they were just so desperate to keep him on. It's like, we'll give you anything. Yeah, what do you want? Right. And he said, nah, I'm done. I just want to move on, And but they would like, anything you want, doesn't matter.
Yeah.
And no.
Yeah.
No.
I mean, sometimes that's how it goes, right? But it's like, but that like upends like an entire like structure of like, I don't know, if I think about like what executives should be doing, I would think you'd be analyzing and trying to like figure out if there is anyone like that in your organization, and at least having them train someone else at the very least, right? Like 20 hours a week is to train 3 other engineers or something like that. And it's never going to be the same thing, but you need some kind of redundancy.
I mean, that could have set a company like that back a year or two in terms of R&D product development, right? Because how many world-class microphone designers are there in the world?
Exactly.
Count them on one hand, I'm sure.
And even if it's like, you're just, so in Doug's example, if he was just training even a technician just to like know how to tune a mic, or maybe it's not for design, you can maybe like survive by just making the same thing for the next 5 years while you find that next mic engineer.
That's might have what they done, and you can like hire like a really top. You can hire top design engineers, but they're still not going to have. There's still a huge ramp for them to come up to speed. In terms of getting that specific product knowledge, for example.
Yeah. And we were talking about Doug last week because I had confounded his name with another Doug. Who was the other Doug that
Doug Self.
Doug Self, that's right. So it's Doug Ford, Doug Self. Doug Self, but he does audio books though, right?
He does audio books and stuff.
That's right, right. So different people, and Dave knows the Ford, not the Self.
That's right. I do not know Doug Self.
Yeah.
And he has a website.
Who does? Both probably do. But
no, Doug Ford doesn't. No, he's a bit of a computer Luddite.
So, okay.
Yeah,
I got it.
No, but Self does.
Yeah.
Doug Self does. The design of active crossovers out now.
Yeah. Yeah.
All that audio stuff. So maybe we can get some audio people, because there's a lot of interest out there for audio design stuff. Yeah.
We've had a couple recently. So we had Nash, who works at Sonos. He was on here recently. He was more on the digital side,
right?
But, and then Kendall was also kind of audio. He does filters and stuff like that. So Kendall Kester Perry was 2 weeks ago. So but I think generally the reason I had also been looking for audio people is because we don't have a ton of coverage, and I think there's a ton in the somewhere in the analog realm. Like depends on where you are. It's like if you're making somewhere from microphones to tube amps, so it's just such a big industry that it's kind of crazy how much stuff's out there. But if people have suggestions on people they'd like to see, we do have a suggestion form on our website for guest episodes, and they can you can throw stuff in there. So it's under the For You link, which is probably not very well named, but there's a
no, I like that how it's categorized. For you, for us,
I guess that is under
that.
For us, it's under suggestions. So
all right.
Yeah, more audio though, maybe in the future. It's a good idea.
What else has been going on?
Well, you may have heard about a conference that I ran last year.
I heard about that. That's big news. Did it?
Yeah, so KaiCon was smashing success last year, as by all accounts. As the person running it, of course I'm going to say that.
Well, I'd say. So how many people would?
So last year was 215 people were there last year. And then we started talking about it, and I was like, look, I can't do it.
Well, you need 2,020 people this year, don't you?
Yeah, right. But I was like, I don't want to do this. I can't do it again this year.
No, you couldn't? Okay.
It was very, it was very difficult last year. It was a lot of time and stress. And
so where was the conference last year? Was it in?
In Chicago. Yeah.
Yeah, right. It was in Chicago.
Yeah, it was at my workspace. Yeah.
I forgot to mention is where the imposter is from.
Oh.
Yes.
The
I'm watching you, Chris.
The plot thickens. Maybe it was me.
Yeah.
Maybe it was my evil twin, Chris, with a K.
Okay.
Yeah. So it went well last year, but we started talking about. We talked about it at the time. We're like, maybe we could do it at CERN next year. And then some of the developers started talking about it. They're like, we really want to do it again this year. And we talked to the CERN folks, and they're like, yeah. So we are going to be having KaiCon 2020 at CERN in Geneva, Switzerland, September 11th to the 13th of 2020. Cool. So it's a little bit later, but that's because we needed to get all the facilities there. They actually have
They've got conference centers and stuff that handles 2,000 people?
They have... not 2,000 people. A lot of people, though. They do a ton of conferences there, and they are, because they're publicly funded, so they have a charter to be a resource for a lot of the scientific community.
Yeah, of course.
And you can look at all the. Oh my goodness! If you look up the conferences that go there, man,
sure.
It's some smarty pants people that are going there because it's obviously it's CERN. There's the Large Hadron Collider there,
and all of them collect spores, molds, and fungi.
Yeah, for funsies. Yeah, yeah. But because of that, they had the resources. So they actually have a hostel on site. They have a restaurant on site that does all the food and stuff like that. So there we go. Analog computing, past, present, and future. February 14th. That's coming up, Dave.
Wow. What would be the average age of the attendee there?
I think they said future. Come on.
Future analog computing. Okay.
Yeah.
But that doesn't involve quantum computing and stuff like that. So
I think it's multiple states kind of thing. I think that's probably what they're,
Oh, okay. So they'll be given lectures on qubits and
probably stuff like that.
Right.
Yeah.
Fun stuff. Awesome. See, I would love to go, but it's
that's
on the opposite
I think
side
that's
of the
pretty
planet.
even farther than here. So yeah.
It is further than getting to Chicago. Yeah.
Yeah.
So that's insane.
I'll be talking about it as we get closer. I'll probably try and fly in somewhere other than Geneva and take a train over just to have the experience, and so maybe flying to Paris or similar. If people are in the Europe area, Europe's not that small, right? But yeah, if people are going, there's a mailing list on the site which is 2020.kaicad-kaikon.com, which is not a great website name, but whatever. We'll link it as well. So.
And the biggest frequently asked questions is, can I get a tour? Can I get a tour?
Yes. Yeah, there will be tours. It'll be tied to the ticket, though, I think, because I think there will be limited numbers.
Of course.
Sign up early. Right now you can just sign up for the email address. But yeah, I definitely want to go for that. Holy crap, I don't know what parts we'll be able to see. There's obviously lots of parts.
Well, everyone wants to see the main receiver.
Atlas.
That's the
Atlas is the picture that everybody sees. That
is the money shot. Everyone wants a selfie with the Atlas.
Yeah, I don't think that's probably not going to happen because I think they will be in shutdown because they're reworking all of CERN right now.
Oh, are they? Okay.
Yeah, they're souping up all the magnets in the loop and stuff like that. And just reading some of the specs, I actually had a chance to talk to someone out here who works at Fermi. So Fermi's out here. In Chicago, they also have a accelerator, and just the power numbers they deal with and the speeds of capture they have to do on these things, and just how much general technology is in there is just so bonkers. And you just I guess whenever you're doing a scientific thing, you're on the edge of what's capable. So it's very impressive engineering. I'm very excited to see it, but I think also just to talk to people that are nearby it. I still haven't done a tour of Fermilab. I need to do that. But it's way the hell out. There's actually they have this monolithic building structure. If you look up the photo online, and then they have a herd of bison that are around there.
What? Okay.
You know the bison. Bison.
Yeah. I know bison.
Yeah. So they were almost extinct in the U.S., but they have a herd that they protect there. And
there you go.
Yeah, it's really cool. So on all the branding, there's bison on everything. So it's fun. It's fun.
Got it.
So yeah, my goal is to pair that trip when I go out to Fermi here in Chicago, is to do that, pair that up with a skydiving. I've never been skydiving, and there's like a bunch of, because it's just a big flat area out there, like go skydiving, then go to Fermilab. I don't know which would be more exciting.
Well, I thought you were terrified of heights.
Oh, I am. But you got to jump out of a plane once in your life, right, Dave?
Right. Okay. Fair enough.
I'm not gonna do it. Dave's talking about, because when I went to Australia, I was afraid to do everything.
Oh, dude, we were climbing down some ladders on the side of a cliff, and you went, "This is my limit. This is my limit." I mean, come on.
I was actually looking at video of that the other day. It was, it was pretty. I'm not a fan of heights. I don't.
Jeez.
I'm sorry.
Okay,
I don't know.
I'm very surprised. You seem rather blasé about going skydiving.
I mean, if it doesn't work, it's a great way to go, right?
Right. Yeah. Okay. Yeah. Fair call. Yeah.
Just a nice, solid splat. That's
right. So it either works or it doesn't.
That's right. That's right.
Well, there is a middle ground there where you land really hard and you break your spine or something like that.
Sure. Well, how likely is that, though? Speaking of things going up in the air, two of our former guests actually worked at this company that's been just announced its existence to the world. Todd Bailey, who was on the show a while back, and Jerry Ellsworth both worked on this small rocket makers running a different kind of space race. So basically,
I didn't know Jerry worked on it.
Yeah, she worked there.
When?
She worked there towards the beginning of when this was around. I think she was doing some of the control electronic stuff, and Todd also was working on that. And so it's an interesting idea. It's
hang on. Where did she find time for that? Because I thought she went straight into one AR startup to the next.
I think when the thing shut down, I think that's when she was working.
Oh, right. Okay. Yeah. There was some downtime there. Okay.
Yes.
Right.
I was referring people to that episode. If people haven't listened to that episode, I list that as one of our top episodes in terms of gut-busting laughter of dark humor. I think it was, I forget what it was. It was like Jerry returns to talk about business or something. Oh, and the demise of Cast-AR. So we'll link that as well. It's episode 394. That's definitely it's basically our small version of the show Silicon Valley. It's basically Jerry
spilling the beans.
Spilling the beans. Yeah. So Todd was working there too at this startup called Astra, which is like a play on Ad Astra, I believe, right?
Okay. All right.
It's like stars, right? Isn't that what Astra means?
Yeah. Okay, fair enough.
And it's like a smaller version, so like SpaceX. I just finished listening to the Elon Musk biography, which is like 5 years old at this point. But holy crap, man, that's the story. Just listening to the depths of the story and everything. It's an interesting listen. But the size difference is really interesting. So it's like a 40-foot or like a 13-meter tall rocket instead of a 20-foot or 100-meter rocket. No, that's not right. 80-meter rocket. So pretty different in size, but in terms of
payload as well. And so they're targeting, for those who plan along at home, they're targeting 165 to 450 pound payload. Yep. So that's
that's not a human.
That's one person. Well, that's basically barely a person.
It's a satellite. I mean, that's really what it is. It's a true commercial play. And for satellite type stuff.
And their cost per launch claiming 2.5 mil.
Right, which is much less than the average for I think they said SpaceX is at about 60 now. I think they're trying to get it down to
$60 million. Yeah,
they're trying to push that down to 30, I think.
Right. But still, that's an order of magnitude greater than this one's claiming. So
right, but also then historically, I mean, I think it's always like cost per payload. And so. Or what is it, price per pound or price per kilogram? That's ultimately the measure I think that they do, because then there's also the cost of that includes fuel costs and operational and everything like that. So
I was wondering who they got their funding from, but it turns out Airbus is one of the funders. A Salesforce co-founder and various other.
Yeah, rich people love space. Let me tell you.
If I had billions of dollars, I'd probably be throwing, $50 million into some space company just so I could go there and hang out.
Yeah,
right. And just and then just be involved. Yeah, of course.
Yeah,
totally.
I do. I mean, I've not as into space as Dave is, as people probably know from listening to this show in the past. But I do wonder just about the logistics of there's just a lot of stuff going up. And like
it's rocket science, dude.
No, I get that. I'm saying actually like stuff in orbit though. Like
oh yeah.
You know, like
and it's just exploded with Starlink. So it's just like
exactly.
insane levels now.
Yeah. Oh, and someone actually, a couple people wrote in about this. We talked about that last week on the show. Look at this, we get to do a follow-up the week after. How different is this? Oh. They wrote in the difference in timing is because fiber is going through glass, which is like much, much lower speed than going through free space.
Of
and
course.
So that is one of the biggest things. So there's a really good video of explaining it with like the guy did like homemade simulations too. So Paul had written in about this, and I forget who else had written in about this, but they're actually like these homemade simulations where he's showing all of the Starlink satellites when they're operational, and like if they're going laser link or if they're going down to the ground and back up. If people don't remember, Starlink is the SpaceX version of space internet, and just the math around it is insane. But like a New York to Seattle link could be as much as half the time of what it is currently, and so that's what I think is going to pay for it. But then it'll also give a lot more access to people around the world, which is pretty crazy. I have a search going on Twitter, and it's a mix of people that are like, it's like I'd say it's in thirds. It's like a third of the people are like speculative investors, a third of them are like just like rah cheerleaders of SpaceX, and a third of them are pissed off astronomers. Let me tell you,
right, exactly.
They are very upset because there's actually a site you can go to, which I think was sent when someone emailed us too. But you can go to and actually see when these are going to be going over. It'll simulate when they're going to go over your part of the world, and so you can see the train of Starlink satellites. But
Tesla had to change the design of them. They had to paint them matte black so they wouldn't be reflective as
reflective. Yeah,
as reflective. Yeah, exactly.
SpaceX,
which was I can't believe like you can like literally do rocket science, get thousands of satellites, design and get them up there, and then not think of that.
Right.
I mean, it's just like it's nuts. Right.
Yeah. I mean,
how can you screw that up?
I don't know.
Anyway, yeah.
So
anyway, so I am watching the ping animation thing now. I guess you could call it. Is it a ping animation?
I think so.
Yeah, something like that. And going from one side of the US to the other, and it's rather fascinating. Yeah. So they jump from one satellite to the next.
Well, no. So right now they don't have the laser links to go satellite to satellite. That's what they're claiming they're going to do.
Okay.
So the first simulation that you watch on that video, which I said we'll link, is it goes down to base stations. So it's basically, and then the idea being that you could maybe even do peering, where instead of having specific like SpaceX base stations, you start to use people's modems in their homes to kind of piggyback traffic and stuff like that.
Got it.
So I'm just amazed at like the idea of like the
so
bandwidth
it's going to be
and throughput,
a distributed computer thing.
Yeah, in theory. I think right now they're just pieces of things. They're just in test mode. So I don't think there is anything out. I don't know if there's a planned release for that, but
yeah, I haven't heard of any services that you can buy yet.
Yeah. There's definitely not. Yeah.
All right. So will these satellites be used? I mean, what's the lifespan of these? Because they're so low orbit, I believe the lifespan is much lower. So do you know what the lifespan is? And will these ones actually be used for services, or are these just test ones that are?
No, I think these will be. I mean, I think they'll be on a much. I think they have the capability to replace them a lot easier. They could decommission and put them into. What are the different orbits? I was really surprised reading that other book about the Iridium satellites. Like, I always just assumed that like it was just like, you just burn them up. Like they're just definitely gonna burn up. And yet there was like a ton of that book was dedicated to like the Motorola lawyers being worried about like someone getting hit by a piece of space junk or like.
Of course, yeah.
I guess I never really thought about it. I always thought that. They always just talk about things burning up. I just assume things burn up. Right. But I guess some stuff can make it through.
Little chunks actually survive, chunks of titanium, other metals and things, they survive and just, fall to the ground at terminal velocity. And
That's not optimal.
No, that's suboptimal.
That is suboptimal, yeah.
Oh boy.
Yeah.
Anyway, yes, it's a mess. And there's not just SpaceX doing it. What are there? At least 2 other companies who plan a similar size system. Like the SpaceX one, Starlink is bad enough.
Right, and that's like 2,500 to 5,000 satellites or something like. It's like
more. They plan like tens of thousands.
Yeah.
Like and there's other companies do, and Amazon want to do it as well, don't they? And or someone. Anyway, multiple companies.
Yeah, I mean, I'd imagine
each.
like to get like coverage. Like I was just thinking about the bandwidth you'd need. Like so you're beaming down to the Earth, fine, whatever. But like the amount of bandwidth you'd need, if you have a dense area, I don't think it'd be as usable, right?
Oh no, it's gonna.
Maybe you'd have to like go from like if you were in like New York City or something, you'd have to like fan out to like the Catskills and then like hop to there, and then maybe that sends it up or something. Because just thinking about how loaded down the satellite over top of New York would be, or any really population center.
Of course, yeah.
So how much capacity could they really get out of that then? I'm sure that they've thought about all this stuff, but it's just like it's interesting to think about.
Yep.
We're trying a new type of ad here at the Amp Hour, which is going to be focused on teaching you something while also hearing from our sponsors. This past week I talked to Daniel from Keysight, who wanted to tell us about ESD and the inputs to your test equipment.
What we're seeing is our support teams are getting these calls and they're getting these boxes come back and they're damaged, and yet the engineer is like, why? What happened? Everything's normal, and then all of a sudden it was just gone. I don't know what happened. We did everything right.
So when I was talking to him, I figured it was going to be some kind of large spark or similar thing.
The most dramatic, obviously, is kind of that wool socks on shag carpet, like an arc, and then the signal just doesn't work. It's actually a lot more subtle than that, and that's what tricks people. So we all know, like, if you touch a board or you touch a scope input and you feel a shock, that's really bad, right? Like that should make you nervous right away. But that's a couple kV to make that arc. And you can even build up and damage equipment with just like 200-300 volts. You make contact with something and it transfers transfers that charge from your body to the equipment. You won't feel it because it's not arcing. It's, relatively low for what we're used to feeling. But the equipment is not ready for that level of voltage coming in, or power coming in. But more often than not, it's subtle. So you start to see more of your tests fail, or you start to see just some weird performance under obscure conditions or even more normal conditions. Part of identifying it is knowing how things are supposed to look, and even comparing it to other pieces of equipment and saying, here's what it looks like on this, here's what it looks like on that. Oh, there's a 10% difference. Is it my probes? Is it something else? Or is it actually... So there's that level of calibration and being aware of what things should look like and understanding when it's your equipment that's wrong versus your device that's wrong. The other one is noise, like baseband noise on a scope or even a RF gear. If you see your noise force come up, that's an indicator that something could be wrong.
And so this knowledge is part of an app note series and some checklists, and also a video series where they showed you how this was looking on the bench.
We walk through, here's what's actually happening on these boards. So we charge them up with a cart or packing material, and we'll take a non-contact voltage sensor and kind of hover it over the board, and you can actually see how much charge is on it. We've also we did a measurement on there where we hooked a current probe around a paperclip that was connected to ground, charged up and connected to the paperclip, and you can see how much amperage is going through that connection using that current probe.
Starting in March, they're going to be bringing back a contest that listeners of the Amp Hour will also remember from past years.
It's called Wave, and we actually have a link where anyone who signs up using the Amp Hour link gets an extra entry. bit.ly/Amp Hour Wave. You can also go to wavekeysight.com and sign up there, but using the Amp Hour link will get you an extra entry, so it's a good thing.
Sign up starting today for drawings that will start from March 2nd all the way to March 13th. They're going to be giving away over 100 different pieces of test gear. If you want to learn more about what you heard here, you can check out the links in the show notes. And now we're back to the program. Okay, let's switch away from internet. Let's switch away to how about some electronics. You've got a chip. You've got a chip that you like.
Chip of the week.
Chip of the week. 2 in a row, man.
Exactly. It is. Let me pull it up.
Let me just say up to the outside, this thing is ugly.
It is. It is ugly.
It's
Dave. Something that a mother loves.
Yeah, right. Only a mother loves. Yeah.
I'm sure its mother loved it.
Yeah.
It is the from Fairchild. One of the originals. All right. Mm-hmm. It is the FSBB 20. and there's various variants of that. But it's the FSBB20, CH60 for those playing along at home. And it got semi-famous on Twitter because somebody posted a photo of its butt ugly package.
Yeah.
And it's an evil package. Yeah. And it's just, yep.
It looks like, if this was going to be like a dead bug, if you were going to dead bug this thing, it would look like a centipede. I mean, it's just got so many legs and weird configurations.
Different types of pins. Yeah, it's a dual inline package. It's a dip package, but it's a combination of a staggered pin, wide spacing.
If it does that, like, doesn't it have to be in line then? Like, is this technically a dip?
It is technically a dip because it's a plastic package. So that's the P part of dip, dual inline plastic package, and it's got pins down both sides, but it's a staggered row one, just like you got back in the 70s and 80s when pin spacing, because they didn't have surface mount rubbish back then, so but they wanted more pins on the chip. And dip packaging was the thing, so they went, well, we can't fit them. The pin pitch is just getting too small. We can't have through-hole, pads. It just doesn't work. So they staggered the pins. So you'd have the zip. I can't remember the exact acronym for it, but you would have the pins would be staggered. So one would be in, one would be out, and they'd alternate back and forth. So it'd be the zigzag staggered pin arrangement. It's still a dip package. It's still a dual inline package.
I always thought the line, I thought inline was like that they were...
Well, it is. Yeah, that's not its correct name, but it's still dip-ish.
Yeah, totally. Yeah, I mean, I think if you said dip to someone and you pointed it in a lineup, someone would be like, oh yeah, it's that thing, right?
Yeah,
but
of course.
I was just wondering if there was like a definition of it, but...
There probably is,
but we don't know what it is. That's what it's come down to. So.
Offhand, we don't know.
Right.
Anyway, it's absolutely gorgeous. I think it's gorgeous. I think because it is right. The people who designed this just went, bugger it. We are not going to compromise on the pin, on the performance of this thing. We're going to get the pin spacing we need, we're going to get the clearance we need, we're going to get the pin current we need, because not only does it have staggered pin arrangements, but it has different width pins on it and different spacings as well as staggering.
That's right.
So it's like the quadruple whammy. And it's got a nice copper heat pad on the top too.
Yeah.
So, anyway,
so
it is.
What
is it in? It is a 600 volt, 20 amp, 3-phase IGBT, that's insulated gate bipolar transistor for those playing along at home, inverter with integral gate drivers and protection.
That's right. Yeah, so basically, you can hook a micro up to this thing and drive it with, I think, 5-volt logic. 5-volt logic, it looks like.
Yeah, it's very cool. And it's 25. It's actually the isolation rate. It's 600 volt rated transistors, but its isolation rate is 2500 volts RMS minimum.
Right. Yep.
Because of the the large pin spacing on this thing.
Yeah.
So it's just it's one of these dedicated system type chips, and if you look inside the block diagram, we've basically got 6 insulated gate bipolar transistors, IGBTs, of course with back diodes in them, and various drivers and stuff like that. So it's if you're into your motory and control drivers, I'm sure I use this all the time. Yeah, I use this all the time.
Yep.
So and they're short circuit rated as well. So even if you short circuit them, they they're not going to snot themselves.
Yep, so, definitely. I was trying to explain to someone. So I did some voltage isolation for a product I'm working on right now, and I was like, well, look, I don't want to have the thing that's out there blow up the thing that's in here. And so that's why I put all this, I've got optos and I've got an isolated power supply and stuff like that. And so I was trying to explain this to someone, and they were a little bit confused about it. And I was like, well, it's like they just might be at different potentials, or if you have a spike, again, you might just want to have, you could have a ground bounce or similar kind of thing, and you want to have protection against that because you don't want your whole system be swinging around like that. I don't know if you would explain it differently.
But transients are one of the big things. Yeah. You've got to design. A lot of people don't design for transients. They'll design, if they design a mains product, for example, okay, they design it for the mains. Okay, it's 240 volt mains. I'm protected for that. They don't protect against transients on the mains,
right.
And that's where you can come a gutser. Because you don't think that somebody switches on a motor in the office next to you, some big compressor motor or something, boom, there's this huge, transient on the mains. And if you can't absorb that energy in your product, you can really be screwed. So
yep.
You can release the magic smoke.
That's right.
So anyway, so this is a great package because it means that with the large pin spacing on here, 2500 volt isolation, of course you wouldn't get that with just creepage. You wouldn't get 2500 volts isolation creepage. You would get clearance. Now, for those who haven't heard me explain the difference between creepage and clearance before, clearance is a physical air gap. So it's between one pin and another pin, or it's between one wire and another wire through free air. And so that's clearance. And you typically will have a voltage rating for clearance, but you also have, in terms of PCB design, but you also have another spec for creepage, and that is the path that goes on. How creepy a
thing is. Yeah, that's right.
How it creeps along the PCB.
So this part is very creepy. It looks like a dead bug, and it's very creepy. So this is high creepage, is that right?
Only when you populate it. Only when you put it on a board does it become creepy.
That's right.
Seriously, right. It's because it's clear as a day before you put it on the board. Right?
Oh,
it's
right,
clearance.
Right.
But it becomes creepy once you install it.
Right.
So that's why you always see me in my videos talk about slot cutouts in PCBs.
Yeah,
so that's how you convert creepage across the board, because you can get contamination on the board. You can get moisture on the board. You can get dust and grime and dirt and fingerprints and all sorts of stuff, and that will actually lower your rating compared to the clearance if you just had the pins separately isolated by the air. So that's what a slot out. So the difference between the pin spacing on these pins allows you to put a nice couple of millimeter, I don't know the exact dimensions, but a nice couple of millimeter slot between all the pins, and then you turn your creepage into clearance, and that's where you get your greater potential.
Yep.
And if you want even more than that, you'll see this in multimeter designs. You'll actually have molded into your plastic case of a multimeter, especially the high-end Cat 4 ones, 1000 volt Cat 4 jobbies, for example, you'll have molded into your case little plastic walls that stick up through the slots in your PCB.
Yep.
So so you've gone to level 3, right? So level 1 is minimize your creep, is to get rid of your creepage by putting in the slot, and then the next one is having the slot is having clearance, and then not only that, you put a physical barrier, a plastic barrier between the two pins. So you've gone from air clearance to, it's got to go through plastic, although it sort of like turns into creepage, then it turns into arc creepage around. So it depends on how tall the plastic wall is, for example, and how high the arc has to get over. So it sort of turns back into a bit of a creepage problem once you put in plastic walls between pins and stuff like that.
Right.
So, or it's a combination, because it's got to get clearance. It's got a high voltage spark's got to jump across the clearance gap between the pin and the wall, then it's got to make its way up and over the wall, and then from the wall to the pin over another clearance gap. But it can happen,
Yeah.
Everything
definitely
breaks down given a high enough voltage.
That's right.
So, yeah.
I was trying to explain to someone, they're like, well, why would creepage ever be larger, or when would creepage ever be a bigger thing than clearance, right? Because isn't the shortest point always between two lines? And I said, actually, yeah, that's true, right? In free space, that's true. But if you had a chip on one side of the board and a chip on the other side of the board, and you had to have them separated by some distance that met the clearance spec, the creepage would actually maybe be shorter because it'd be going around the edge of the board. And that's how I help people kind of like visualize it, is like if it's kind of slinking along the board itself, instead of going obviously in free space, in air, you'd have to go kind of like just along the edge of the board, or rather you'd be kind of like surfing just above it, and so the creepage would be a little bit closer. So that's kind of how I think about it. Yeah.
And another trap for young players with creepage and clearance, it changes with altitude.
Oh yeah.
So if you're designing products in say the IPC spec for PCB clearance and creepage, for example, you will have a limit to the altitude. Above 10,000 feet is a different figure again.
Yeah.
It's like it doesn't just magically become different at 10,000 feet or whatever.
Right.
But you've got to have a line.
But they put it somewhere.
Right.
Yeah.
They put it somewhere. But yeah, it does change with altitude. So there you go.
Yep.
So that's why you'll have altitude specs in multimeter manuals and stuff like that. You'll go, oh, it works up to, X thousand meters or something.
Right. That's why you never take it on a plane,
Right.
That and the pointy probes, they'll take away your pointy probes at the security check, and then they'll probe you instead.
Anyway, so I love no compromise designs like this. They just went bugger it. We're designing this thing to a spec, and the pins will be what they are. Mm-hmm. I just beautiful. Thing of beauty is a joy forever.
Yep.
Yep. Brings a tear to the eye.
Yeah, definitely.
So I don't think it's ugly.
I think it is still. Sorry, but
no, it's gorgeous.
But it's well designed.
Gorgeous package.
Yeah.
And people go, oh, what a pain in the ass. But it literally takes you less than 5 minutes to do a new footprint for that in your CAD package. If it takes you longer than that, you're too slow.
I think it's mostly a pain in the ass. It's already through hole, so it's already a pain in the ass. So this is
why? What's wrong with through hole?
Well, from a assembly perspective, it's just not as easy. But if you're doing high power stuff, you're already in the realm where you're like, yeah, there's going to be some through hole components. Getting
exactly
even the biggest D-pack type of things. It's sometimes they just aren't big enough. But I think that what you're talking about with creepage and clearance, and then also if you kind of roll in the the power specs of things, all that stuff together, kind of it helps you kind of take a new view on why certain packages are the way they are. Or even seeing sometimes in certain pin spacings are weird, maybe underneath an LGA or something like that. Sometimes it's due to that kind of stuff as well. It's just you need to hit these certain specs, and that's why you've got a pad over here and a big pad over there, and it's just kind of this. It looks like there's no logic to it, but there very much was.
So that is Chip of the Week?
Yeah.
And you might think this is obscure, but no, DigiKey have a stock of 83,000 of these.
Yeah.
Oh, sorry, 78 in stock. At the factory, there's 83,000.
Yeah.
Sorry, I got all excited.
Yeah, well,
Anyway,
I'm sure these things blow up quite often.
Yeah. Right.
It seems like the kind of product that might,
Yeah. But it's not to order. That factory stock, you will get that in a week or two. They'll just order it. If you place the order, I need 80,000 of these, please, DigiKey.
Yeah.
And it's at what is it, $21 a pop. For 500 plus quantity.
Right.
But yeah, it's probably the only thing that does the job.
Yeah. Yeah, it's very possible.
I mean, it's like, oh yeah, you can do it with discrete IGBT transistors and other drivers and stuff, but sometimes price doesn't matter for parts. In low volume or specific, in very high margin products and things like that, you aren't optimizing your BOM cost.
Right.
You're always thinking about it. Engineers are always thinking about it because we can't bloody well help ourselves, because we're just optimization beasts.
That's right.
And yep.
That's what my dating profile used to say. I'm an optimization beast.
Optimization beast. That's got to be the title of this episode. Optimization beast.
Oh boy.
Yep.
Yeah.
Do it.
Okay,
Do it.
Fine.
All right.
All right.
You can update your Tinder profile. Chris.
Yeah. Well. Yeah. No.
Optimization. That's great. Anyway,
I was asking today on Twitter. I was thinking along the lines of being an optimization beast. I've been thinking about this recently of like the time I spend at different parts of my office and stuff like that too. And I was thinking I'm not really spending that much time at the bench these days. And I was trying to think of what is my mix of time at the bench or doing layout or like programming or writing docs and stuff like that. And so I was asking on Twitter, and a bunch of people responded, but it's kind of all over the place. It really is pretty. It is obviously very project dependent. I was wondering if you had numbers for yourself though. If you think about it like a standardized product that you've worked on, what is your mix of bench time versus layout time versus programming or docs or meetings or whatever?
Oh, okay. Well, you have to be talking about company work instead of my own projects.
If it was your projects, it would be 80% forum time and then 5% Twitter and then whatever else.
Yeah, just bum it around,
Yeah, right.
But no, when you're dedicated to a task, it depends, and it depends on the company that I've worked at.
Sure,
I've spent days just documenting a screw.
Yeah, right.
When you're working on stuff for the military, that's part and parcel of doing that.
Right, and your meetings are going to be much more
Yeah.
intense, and there's a lot more overhead and stuff like that.
And then you work at more less regimented companies like Altium, for example, and it's just like, it's just 100% just doing stuff. There are no meetings. There is no paperwork.
Right.
There is no, there's just nothing.
Right.
Documenting code? No, don't bother. That's a waste of time.
Right. Yeah, like getting stuff working and like high speed kind of stuff too. Yeah, I guess I think about that too. I guess the thing that I always like I've been thinking about like a lot of like task switching type stuff, and I've been, so like my days now are kind of more task switching like between clients, and it is kind of hard to do that. But then I was thinking like, well, but in projects usually you have these phases. You're like, okay, I'm in hardware phase, and I'm looking at data sheets, and I'm doing layout, and it's all very hardware focused, and then maybe I go and build it myself, and I'm time on the bench, and then just bring up's got maybe some code, maybe some looking back at the schematics and stuff like that. But then it's like then the firmware stuff, and it's like I feel like right now I've been doing so much firmware, which is interesting for me, but it's just been like the switch back is like a pretty drastic thing, and like it takes some time to kind of get back into it and like think about like how things are working and software workflows and all that stuff. I don't know.
Well, when I'm getting a project done, I force myself not to task switch, because it just kills your productivity. If I'm laying out a board, do not talk to me for 2 days.
Yeah.
Or do not talk to me for a week.
Yep.
For example, it's like, no, I'm doing a board design. Bugger off.
Right.
Right. It's like I don't want to know about anything else. I want to focus. I want to be in the zone.
Yep.
Same with coding as well.
Yeah. I think those are similar in that like you're just very goal oriented kind of thing. It's like get this thing to the point where it's working or out the door to get it shipping and whatever else.
Yep.
Yeah.
No, it's just task switching kills productivity.
Yeah.
It really does. Just absolutely destroys it. But sometimes you've got no choice, because you're back and forth between data sheets, and I'll add this footprint to the package, and then I'll do this other thing, and then I'll try and do some design calcs, and then I'll do some other stuff, and you're all over the sheet. You can't help it. But once you're dedicated to a large task, you shouldn't task switch.
Yeah. Yep.
You should head down, bum up.
Definitely. Yeah. My the firmware thing I've been dealing with is like I have 2 UARTs that I'm working with, and I'm learning the hard way that like
software, hardware, UARTs.
Software, the hardware is fine. It's all, I verified it all works, but I was like,
no, but you're using hardware.
Oh
UARTs.
Yeah, sorry, the hardware UARTs. I'm not doing that.
Are these inside a micro?
That's right. Yep. And but I'd been like having the easy life, just doing printf out of the first UART. Everything's going fine.
You young whippersnappers
with
your hardware UARTs,
Yeah. Yep. Super easy, right? And then I was like, oh, how do I write to that second one? And then that kind of like put me down the rabbit hole, and like of like, you have to actually, it's not just this magical function that pops out data anymore. It's like you have to when you print after one, you can't print after the other. And well, actually you can, but
really.
Yeah. I mean, you have to like write a new function basically that allows you to switch between the two. And I was like, oh, okay. So that has me.
Why wouldn't it be the one function and then you pass it the port you want to go to?
That's just I would have to write that basically, and it's totally possible to do
that's
that.
A given.
Well, no, I mean with like a standard I/O, like you could just with a standard I/O you could just like push it out to the you basically tell it, hey, it's going to this port and it's fine, right? But so it's.
Oh, come on! How is this a complaint? I mean,
it's not a complaint. No, I'm just saying this is what I've been.
This a whinge?
This is what I've been dealing with. I'm doing firmware stuff more than I used to, and I'm like, oh, okay, this is interesting kind of things. I don't know, like
the struggle is real.
The
folks.
Struggle is real. Yeah, I guess I'm having empathy for firmware people more than I used to. I don't know.
Right.
I was just on Embedded, so I think after this I will be cross-posting the episode. But I was just on Embedded talking to them. I talked to them
complaining about
on Saturday.
Getting his UART up and running.
It was a little bit less complainy, but it was more about the general flow and learning and relearning firmware stuff. So that'll come out midweek. I think next Thursday we'll have that come out on the Amp Hour channel as well. So it was a good chat, but it was not as whingy as Dave said, I guess.
Okay.
I'm sorry, Dave. we never whine on here otherwise. So
no, we don't. No,
right.
we're not known for that at all.
Right.
Yeah.
One last thing I wanted to bring up before the end of the show. Former guest of the show and friend of the show, Ron Kwan, has come out with his third book, and I don't think it was on the list last week when we talked.
No, it wasn't. Oh, yeah, it was, but we didn't get around to it.
We didn't talk about it. Okay, yeah. So it is about troubleshooting circuits. So relevant,
Sweet.
Very relevant to this crowd.
For sure.
Yeah, and so he's been working on it for like a year or two now, and I just ordered a copy. I'm very excited to try it out, but it's his other books. So he has he had one about RF and one about I forget his other one. The electronics from the ground up. That was the other one. So we'll also link to Ron's episode. But new book coming out, so if you're interested, check it out.
Sweet.
Yeah.
And that's it for our AMP Hour. We are trying to keep the episodes to an hour.
Yes, that's
right. Including interviews and stuff like that. We'll try and keep them.
We'll see.
That was some of the feedback. We'll see.
Yeah.
If it's a really important guest, we'll, let them go on for multiple hours. But people do like consistency. So, but please leave your thoughts in the comments about that.
Yeah, we do have a comment section. Who knew?
Yeah, we do. Go figure.
All right.
Catch you next time.
See you later, you optimization beast.